Alright, this video is for Miss Ferris. I'm just out here in my lab right now. I just want to show that this function generator does work. Works pretty well. As you see, I got on the oscilloscope here, and I've got it on a telephone test set for now. Here's another one. This is just an easy source of an amplified speaker. It's the only reason why I have it out here. But anyways, got all my phone stuff and whatever else out here. Bunch of projects, fire alarm panel. Anyways, so as you see, I've got the waveform here on the oscilloscope display. It's at 0.2 volts per division. There we go. Currently playing about 200 hertz, approximately 200 hertz, because we got point on 2 times the 100 hertz multiplier, so 200. It's on a sine wave, and that looks more like a triangle wave that's been rounded over a little bit. I would assume that's actually probably what the sine wave looks like, or maybe honestly, that's probably the capacitors are old in it. I mean, it's an old thing, so the capacitors are probably bad in the filter, because the way they probably get their sine wave is by using a I can't remember what the name of it is, but it's where you have an inductor and a capacitor feeding into each other for basically converting a pulsing wave like this, or a triangle wave, or a square wave, and you convert it into a pretty okay looking sine wave. Right now it is on the sine wave. The triangle wave looks great if I can get it to load. There we go. There is a triangle wave, and the sawtooth wave looks pretty alright. These buttons are really dirty, so it's kind of hard to get it to. You can kind of see the square wave. It looks pretty good too. There we go. There's our stuff. I'm not really sure what the offset is for. I'm gonna assume it's some sort of fine frequency adjust. I could pull out the frequency counter and hook that up if I really cared enough, but if I ever use this, I'll probably have this right next to it, so that way I can send the TTL logic output into this frequency counter, so I can actually get a digital frequency read out of the thing. But for now, I mean, this will work good. The main reason why I need it is I'm building circuits. I'm sorry, I'm building a bunch of filter circuits, and I need a signal source, so this is gonna work great for me. But as you see, there's a level control. We can go ahead and change the frequency. There we go. There's also a DC offset, which I don't know what that really does. I'm going to assume that would give it a DC offset. But I'm going to assume that uses the VCG input, because on the scope you can see there is no DC offset at all. When you flip it on or off, it doesn't matter what that switch is doing. There is a cool 1 kilohertz modulation, which doesn't work on triangle wave. I guess only on sine, if I can get it working. Or bad sine wave. You can flip it on and we get a 1 kilohertz modulation. As you can see, it's modulated at 1K. Which I can actually demonstrate ripple control signaling by going to 10 hertz multiplier and going to 60 hertz like will be on your power line. If I can just hit it, there we go. There's our 60 hertz. You can barely hear it there. In the I found that funny. The 1 kilohertz modulation is so overpowering. Let me change the voltage range here. There's our 1 kilohertz modulated sine wave. So 60 hertz with a 1 kilohertz modulation to it. And you actually have a 1 kilohertz output, so you can turn that on and take the audio and connect it here. And then you get straight 1 kilohertz output. Shove that back in there. Which is honestly really useful. Actually, my communications analyzer also has a 1 kilohertz level adjustment out, and it can feed it out the modulation output. So yeah, pretty cool device. I mean, works pretty good. Only thing that if I would use them, the thing I would do is I would definitely do a recap of them. Probably not too expensive of a thing to do. And these buttons, as with any buttons with age, they are pretty crusty. Well, I mean, they feel fine. They're just noisy. So they could use a squirt of deoxit. So, yeah. That's my conclusion. And on the outputs here, you've got a high output and a low output. I'm going to assume the high output is the... I don't really know what the high output is. I'm going to assume it's like 5 volts. And the low output is just a low voltage output, I'm going to assume. I haven't really checked that out, but that's what it seems to be. TTL output is actually just a pulse. It gives you a clock pulse per frequency. So you can set a frequency and get a TTL clock pulse out. VCG input, not really sure what that's for. Voltage controlled something, I don't know. And then your external 1 kilohertz modulation output. So, yeah, these things work pretty well. And, yeah, have a good day.